And hi everyone, I'm John Diamond and welcome to the November Intuity Tech Talk. Today's session we'll be talking about user-defined polling. With me today is Pete Bartz, and we are part of the US-based engineering team for Intuity. So today we are going to be using Intuity Network Analytics, commonly called ENA. And our BMC customers know it as Intuity Network Analyzer for TrueSight. ENA is the upgrade to Intuity 16.5. For those of you who are still on 16.5, or possibly even an earlier version, and are planning to upgrade this year, we invite you to contact your Intuity system engineer. We are more than happy to discuss any facet of the new product with you and help you devise an upgrade path that makes sense for your organization. Right, so let's step on again. So let's get started on today's topic, which is user-defined polling. Now, I just want to touch on the high-level concepts of what user-defined polling brings to the table. Fundamentally, in its ordinary standard use, there are three main use cases that are addressed by user-defined polling. And it's an area where you can extend functionality of the ENA product. Firstly, if you have a component such as a device that you want to add an additional attribute to that doesn't exist in the standard product and define how you're going to poll via SNMP to satisfy and populate that attribute, then you can do that. There's actually a wizard, a workflow wizard provided within the product that allows you to be stepped through that whole process. For example, if you had a wide area data compressor and you wanted to represent the data compression ratio, that's not an attribute that we ship as standard as part of our configuration. But you would, provided that information is available within your data compressor, you would be able to create a new attribute and define how that information would be gathered via SNMP to populate it. Another use case is that you've got a standard attribute that is part of the standard product, but you've got a device for which we don't have the necessary standard logic to populate it from its vendor proprietary MIB. Take, for example, a chassis serial number. There is no industry standard way of representing that in MIBs, so that's always taken from vendor proprietary MIBs. And it may be that we've not yet extended the support for your particular make and model of device. Now, what I would say there is that we are more than willing to do that work for you. That's one of the roles of our support team, and all you would need to do is create an SNMP dump of the device and submit it to the support team, and they will add that support for you. Now, if you need any assistance with that, just reach out to the support team, raise a ticket, and they'll be able to help. But you can do it yourself. And finally, there is a mechanism whereby you can create new components in the data model to represent information that is taken from MIB tables. So, for example, if you were to have a table of, let's pluck an example out of the air for that one, how about files in a flash file system on a device that's represented through SNMP on the device, then you would be able to create an object to represent a file and define how that would be discovered if there are multiple files in the file system and how all of the attributes for it would be populated. Now, that said, we're not going to be going through any of that today. And the reason being is that all of that is already not only documented, but we have available to you a whole set of videos about it. Let me show you what I mean. We've got, within the standard product, a link to our help system. If you were to go up to the main menu Go down to Help, and that takes you into the ENA Help Center. By the way, you can get that directly from the Enturity.com website. Just go to the Support menu. On here, we've got a search feature, and if I were to search for user-defined polling, user-defined, and it's already getting there, it's filling in as I go. What is user-defined polling? Here we go. There's an introductory article here, and that there's a video that takes you through the general high-level concepts as well, and introduction text on here. You'll also notice on the right, we've got links to other aspects covering what I've just been talking about. There's actually a bonus video available, which is not covered here, about event raising. And if I were to go back to the main menu, you'll see here that we've got a video section. And under videos, not only have we got the archive of previous tech talks, well worth looking at when you have a moment, but under video tutorials, there are a whole raft of short video tutorials about a number of different aspects of the product, including these 5 videos here. And the one that was not covered in what I was just showing you is all about event thresholds and how to define them. So all of that is available online, well worth taking a look at. Now, that said, let's go back and take a look at what we're going to be doing today. I'm going to be showing you an aspect of taking event raising from user-defined polling to the next level. And then Pete is going to take over and show you a use case for using user-defined polling which doesn't involve SNMP access. So I said that the standard use case was implementing SNMP polling for various reasons, but you don't have to use SNMP. One of the aspects of the configuration is a section called the method, and we generate default syntax for you as part of the way that the UI works. And you may have thought, if you've ever looked at this, why do we expose this somewhat ugly syntax and allow you to see it? And the answer is that we allow you to modify it and create your own. And you can go way beyond standard functionality if you want to do that. So that said, let me just take you into what I'm going to show you about the raising of events. I'm going to go back to my browser. And what I'll show you is that I've already implemented a bit of user-defined polling. And I've got it demonstratable here on one of my routers. And if I go to the attributes, I'm going to filter that long list of attributes down to those that contain TCP. And what you'll see is that I've got this attribute called TCP currently established. And when you implement the user-defined attribute, you'll actually see it appear twice. And you might think that's a fault. It's not. It's actually by design. You'll notice that one of them has a stream associated with it, and one of them doesn't. And the reason for that is that it actually has effectively 2 personalities. A user-defined attribute can be thought of as an object attribute, which doesn't have any history associated with it. But it can also be thought of as a stream attribute that does have history associated with it, multiple samples going back in time. And so it can behave in 2 different ways, which is why it has 2 personalities. If we were to look at the TCP currently established, let me just show that on a chart. This morning, that attribute, which shows how many TCP connections there are currently established to that router, was at 0. But then, about an hour ago, I made 2 connections. I've got 2 remote terminals connected. You can see them up here. And so that value is 2. Now, the reason I did that is that back here, I've also got a threshold associated with it. And I implemented a threshold. And if I were to go back to the router and go to the Thresholds tab, and call down user-defined, you'll see that I've got this user-defined threshold, which is using the critical threshold capability of the user-defined configuration. And I've set a value here of 1 connection. If there are more than 1 connection available attached to that router, it is going to raise an event. Now, by default, it would just raise the user-defined critical threshold exceeded event. Now, I could have a dozen different attributes being user-defined polled for that device. And I've only got 4 different events available to me based upon the 4 different thresholds that you can set up within user-defined polling. And that wouldn't differentiate cleanly between those different attributes. So what I want to show you today is that you can put in a rule into the event management system that will allow you to create a custom event that clearly identifies what it is that's being warned about. So first of all, let me show you in user-defined polling. If I were to go in and take a look at the attributes that I have here, you'll see that the TCP currently established configuration, which this is all based around, if I were to edit that, then take a look at the events. I've set up a threshold event. I've got these 4 different options here. The top 3 allow me to generate events when the value goes above a threshold, and this last one allows me to generate an event when it drops below a threshold. So that is the threshold, and that generates the event. If I go into the event management system, then I've added a rule within here. And if we take a look at this folder that I put it in, you'll see what this rule is doing. First of all, I've given it a name, that this is to deal with the TCP currently established custom event. And what it's going to do is do 2 tests. The first test, and both of these must succeed in order for the action to take place. The first one is going to be a test that the event that has been is processed is actually the user-defined attribute value critical. Now, the critical here corresponds to that critical threshold. And remember, there are 3 different events that can be raised for a northbound crossing of the threshold. So that's the event that will be raised. And if it's that event, it will then test to see whether this particular special attribute contains the name of the attribute that this particular bit of user-defined configuration was populating. So this is really the trick I want to show you. When you create a rule, let's say I'm going to add another rule, I could do an event attribute test. And when you do that, you get a list of all of the attributes that are provided with an event, and you can pick which one you want to test. These ones down the bottom here include the source external ID. Now that sounds a little cryptic, but in reality, it comes into its own in this application because it contains the name of the attribute that this threshold event is related to. So at this point, all I've done is tested to see whether it's equal to the TCP currently established string. Now that must be put in double quotes because this is Groovy syntax down here, and a string represented in Groovy must be in double quotes. You just say it's equal to, and then the name of that attribute. And if both of those tests succeed, what do? We go here. We use the set event type action, which changes this particular event so it's no longer a user-defined attribute value critical event. We turn it into a custom event that I've already created, and I'll show you in a moment, and I called it TCP currently established count high. So it changes it into that. Now it also resets its severity to the one that was defined within the event. If I were to sort by the category column here, it brings the custom events to the top. This is the one I'm talking about. That is what I defined. I've given it a name, and I've given it a default severity. Instead of being critical, I'm saying this is a minor level severity, so that would be yellow, level 2. And the result of all of this configuration, when I go back, take a look at my router, having crossed that threshold, so it's got a value of 2, when I look at the incidents that were raised as a result of the events, you'll see that we've got the TCP currently established high incident having been raised, and it is severity 2, rather than the critical severity, which would be a red, which would be a level 5. So we've converted this event into this new one, the custom one, that is clearly obvious what it's about, and it's got the same details that was in the original event, and that tells you what the threshold is and what the current value was that crossed the threshold. If we were to go back and take a look at the events, what you'll see here is that that is the event that was actually raised, and that caused the incident to be automatically raised. So that's how you can create an event and incident with a specific custom type in order to represent your threshold-based events. So with that, what I'm going to do is hand over to Pete, and he's going to show you how to go beyond SNMP management with user-defined polling.
Thanks, JD. All right, that was outstanding. Let me share my screen out. Started on this other segment. So, as JD mentioned, the traditional kind of a classic way to use user-defined polling is to extend the data model, adding attributes, maybe modifying an attribute that we're already including in the product. And these things done via SNMP queries and using user-defined polling to go in and query the devices. I'd like to take this a step further because the capabilities of user-defined polling allow you to talk to the Intuity data model. And the use case that I'm going to share today is one that actually came from one of our customers. And that is, we monitor at a port level utilization and traffic and a wealth of other metrics. But within the construct of traffic, we monitor traffic every 5 minutes. So we're looking at 5-minute average traffic, bits per second, megabits per second, what have you. And over the course of a day, especially in a business setting, what this customer found is that traffic patterns became more of a bell curve. So between 9 o'clock and 5 o'clock in the afternoon. So they would have more people in the offices, so they're going to have more traffic. What happens is, over a period of time, we're going to roll traffic data up from 5-minute to hourly to daily averages. And what this customer asked us to do is look a little more closely at a daily average, because a daily average that covers 24 hours includes a lot of time periods where there's nobody in the office. So what they'd like to do is they wanted to have a better average picture of the amount of traffic on this link, on this interface. And this is actually a WAN link for a specific office that representing their daytime hours and their business hours. So the concept of prime time comes in. Prime time is a concept that you've seen if you've used some of the reporting features in Intuity. There's prime time definitions where you can actually have a report run around a set of prime time hours. You can actually take that same construct and apply it to user-defined polling. So what we actually did, and I'll show the example of how we did this, but what we did was we actually looked at a daily average and we applied prime time over that average. And you can see that being represented in my dashlet right here. So I've just modified the port-based dashboard to include a new metric that I've added to the system. And what this is a representation of the average over a prime time period. So my prime time, and I'll show you what that definition is, but my prime time is Monday through Friday, 9 a.m. to 5 p.m. Tell me the average for those data points. Don't include any of the data points for any time periods that are around that. And by the way, don't include any data for things like Saturday and Sunday. And to be honest, when I came into the office Monday morning and I looked at my chart and I saw these gaps, I freaked out a little bit because I saw there was no data and I thought there was something wrong. But actually the system is doing exactly what it's supposed to do, because these 2 days represented in this gap are Saturday and Sunday. And I didn't have them in a primetime declaration because I don't care about traffic over the weekends. So it's doing exactly what it needs to do, and it's actually giving me that business-focused daily average. Now let's take a look at how this is actually set up in the system. So to set this up initially, you would go through the user-defined polling wizard. I'm not going to walk through the mechanics of actually putting it in place. I'll show you what the results are. But you would select the polling wizard here. You would select a device to use as a basis, and then start setting up your attributes and the collectors from the wizard. So once I've got that set up, what you'll see is I've got 2 attributes in my system that I've added. I've got an inbound traffic primetime daily attribute, and this is just the name that I gave it. And I've got an outbound corresponding attribute. Let's take a look at one of the attribute definitions. So this is the inbound traffic primetime daily attribute. I just put a display name and a description on it. I tried to map the display name to something that's the attribute naming for traffic in the system. So in the case of a port for traffic, we have an attribute called inbound traffic. So I wanted to keep the names the same because when I'm looking at all my attributes, I can see everything together, sort of in that list. The object type for this, I'm looking at a port. So this is, I'm applying this. You could apply this to any metric in the system. You could apply this to CPU, in which case your object would be a device. I'm setting this up to display as a traffic type of a metric. It's a 64-bit, floating point data. I've actually set my polling interval at 5 minutes. I've only done this really for the tech talk to be able to show you data. In production, I would actually not use 5 minutes. You could use 5 minutes when you're doing your initial testing. But in production, I would set this as a daily polling interval, because at that point, you can actually keep those daily samples for up to 28 weeks. So this is something that can, this is what I would use in a normal setting. But if I'm setting up, that initial testing period, I would set it up with 5 minutes. And you can go back and change your polling interval on this attribute after you've created it. So I can always change it to 1 day from the 5-minute setting. The other piece that we'll look at, and this ties back to what JD talked about, is setting the events for an attribute. Now, I've actually set a critical threshold attribute. I've also set a low traffic threshold, because I've got a capability now where I'm actually measuring bits per second. So I could actually put a low threshold on here and actually account for something where maybe I have a brownout condition on a WAN link or something like that. But if I take a look at the critical threshold as an example and go in and look at how that is configured, I've actually got this set up as its name. I've put it in a user-defined polling threshold group called traffic. I've just created this group name as a title. I've set a maximum and a minimum value and a default value. Now remember, this is all in bits per second, so remember your zeros when you're setting these up. That's the definition for the inbound traffic attribute. So very straightforward to set up in the wizard. Let's take a look at the collector. So for every attribute, you have to have at least a collector that's going out and defining what is it that I'm collecting. And this is really where the cool part of this method comes into play, my ability to actually take data that's already in the system and manipulate it and roll it up in a way that actually has meaning for my organization and the use case that I've got. So this, again, is a collector that's tied to my inbound traffic daily attribute. So I've got the attribute set here. is over a port type of an attribute. And because I'm actually collecting data from the database, I'm not polling a device directly. I don't have to worry about the index. Normally, if you're setting up a user-defined polling collector for a port, you're going to have to indicate, the type of indexing that would be used to actually iterate over, that device and then through its port indexes. But in my case, I don't have to worry about that. Let's take a look at the method, because this is the syntax that JD mentioned earlier, where, why do we expose the Stormworks definitions and the syntax that we use in the data model for you to be able to manipulate. And, this is a use case that's, perfect for that type of, capability for you to be able to do what you need to do. Now, if you have a question, if you're trying to do something with this and you have a question around the syntax, certainly open up a support ticket and we're happy to give you a hand. But this is the example that I wanted to be able to share. So this is Stormworks Syntax. And the key with this is I'm actually defining a prime time period. Now, the prime time actually includes a starting time and an ending time. And you're actually not limited to the boundary of an hour. I could have this at 9:10 in the morning to 17:59 as an ending time. So I can define whatever the time frame is that I want between midnight and 11:59. The next two pieces here are the days. So this is a starting day and an ending day. And the starting day, the days are defined as 0 through 6. And if you take a look at day 0 would be a Sunday. So if I wanted to cover 7 days out of the week, I would do 0 space 6. In my case, I want to do Monday through Friday. So I'm doing 1 space 5. So I've set this up as a variable in the system and in this command set. And I'm going to go through and I'm going to look at an existing stream that we've got. And this is the traffic data rate. And you can actually find this if you're looking at the system information and you go into the data model. You can actually find this. And again, if you have any questions, certainly reach out and we can give you some guidance. But I'm actually going to iterate over this stream. And I'm going to look specifically at yesterday's data because I want to find a daily average over a complete day. So I'm actually looking to run this right after midnight and then look at yesterday. So I'm looking at a period of time that looks at a starting and an ending period. And again, this one at 1 day is telling me to look at 1 day completely. So I've got a starting and an ending period. And then I'm referencing my prime time calculation. PT is just a variable name. You can call it whatever you'd like. But this is actually substituting my prime time declaration right here. So this is going in every day and iterating over yesterday's data, all the 5-minute data from yesterday, and pulling out only the samples that are between 9 and 5 and calculating an average. So very straightforward. And actually this collector, once I've got this in place, is going to start working. And I've done a similar collector for outbound traffic and a similar attribute for outbound traffic. So once I've got those 4 pieces into the system, user-defined polling is going to automatically go out and do those initial calculations. And I'm going to see my first data point and my first sample in the system. So I can represent this as a dashlet. Again, I've changed my time period over this dashlet. In general, I'm only looking at the latest 24 hours. But if I just look at 24 hours worth of a daily sample, that's not going to give me much. So I'd like to look at the last 7 days. I can make this 28 days if I'd like, if that was helpful too. I can take that a step further if I want to look at the actual, the attributes. If I clicked on the attribute dashboard for this interface, I'm just going to search on prime time. I'll just search on prime. And you can see again that, as JD mentioned, there is a object attribute and there is a time series attribute. The object attribute is going to represent the most recent sample, and the time series attribute is going to represent the entire stream. So if I took a look at this, I could show the history. And I go back, a number of days since I actually put this calculation in. But if I go to the ending time samples, you'll see I've got a lot of null data points. This happens to be a Sunday, which is outside my prime time declaration. And I've got the most recent sample that I've run at 7:30 this morning because I'm still running this at a 5-minute frequency. So you've got access to all the samples. You can certainly collect these and do your own statistics to validate that the samples are correct. But one of the other things that you can do is I just created a simple chart that overlaid my traffic, my inbound traffic to my inbound primetime traffic. So what's interesting here is if I'm looking at my daily average, remember that your prime time is an average of not the entire 24 hours, but an average of just your prime time window. So in my case, if I'm looking at prime time, I'm starting about here, somewhere in the neighborhood of 9 o'clock in the morning, so right about here through the end of my day, in calculating the average for that. So I think this is another good example of not just using user-defined polling to collect data from a device, but actually use it to manipulate data that's already existing in the system. I think with that, I'll turn it back over to Pat, and we'll see if we've got any questions.
Yes, we have one. If we can define custom attributes and polling cycles, how can I apply them to a class of devices, for example, all Cisco routers, versus applying it individually?
Actually, Pete, do you want to just show the filter that allows you to restrict what it applies to? It is a good question. Certainly, you wouldn't want to have to set up this type of configuration for each and every device under monitoring.
Sure. So in the definition that I've got in my attribute, there's a section here for the filter, and I can edit the filter. And the filter is looking at my system to look at all the different types of devices. And I can use, if I want to look at just Cisco devices, I can select that. If I'd like to add Cisco devices and Fortinet devices, or Cisco devices and SonicWall devices, I can have multiple filters in here as well. If I'd want to take this beyond just the Cisco Enterprise ID, I could add this in. And I could actually modify this to include, I'd have to pick an arbitrary number, but if I'm looking at a class of routers, if I'm looking at an ASA, or if I'm looking at something else, I can just extend that, that numeric to include a little bit further filtering. So the filter is defined in the attribute, and it's also then let's see, it's just used then. It's filtered, it's included here in the collector as well.
And given, in fact, that that is Stormworks syntax, you could look not only at the enterprise OID, but you could also look at the type of the parent device. And we have different type settings for routers, Ethernet switches, firewalls, etc. And you could put a qualifier in there that it's not only from a given vendor or collection of different vendors, but also it is specifically a router, for example, and so it will ignore all switches and firewalls. So you've got a lot of flexibility, and once again, as Pete has said before, if you need help with the syntax there, just reach out. We'll help you.
JD, I could even use something like a syslocation field. I could use a syslocation attribute. So based on the location of a device, I could poll it differently.
You've got a lot of flexibility.
Okay, great. Thanks, JD and Pete. Another question came in, and how can I use the attributes to monitor device volatile chassis memory?
First of all, if you can locate an SNMP OID that will represent the chassis volatile memory statistic, then at that point, if you want to create a new attribute specifically for that at the device level, you can go through the polling wizard, the user-defined polling wizard. Pete, do you want to just show where that's launched?
Sure. Let's take a look right out of the administrative section here.
Yeah. So down bottom left, user-defined polling, and that link takes you to the wizard. You just pick a device to use as an example, and then you go step through it. All of the steps required to implement a custom attribute with a custom collector to go with it to define how to gather the data are covered in the online help, which I showed earlier. There are specific video tutorials that will take you through step by step. Okay, Pat.
Great, thanks, JD. And then we have another question. I have a multi-server environment. How do you replicate a user-defined polling configuration?
Pete, as you've got the screen at the moment, do you want to just take a look into the file system and point out the online help, the help that we've got available for that?
Sure. Let me.
Yeah, it's a good question. Certainly, if I've got 10 remote servers and I implement it on one, then I definitely want a way of avoiding to have to do the whole lot again through the UI 9 more times.
So in the Intuitive Lib Tools directory, there's a UD polling section. And in here, there's an export and an import SQL query. So you would do this from the command line. And there's a README text here. If I pull this up on top of my screen, you can see it. So this will give the instructions as to how to export from one server and actually import into the others.
Yep. Just one thing to be aware, I believe that will replace all of your user-defined polling configuration on the target server. So it is recommended that you do your development on one server, and so that server has the composite of all of your user-defined polling configuration, and then when you export it, it will bring the other servers in line with that initial server configuration. So it doesn't wipe out anything that you don't want wiped out. So just be a little careful with that.
Great, thanks, JD. And it looks like our last question today is, can Pete's example be converted to a percentile calculation as well?
I can take that one. That's perfect. So let me just slide another screen. I've got a telnet session into the debug port for Intuity. This is something that you've got customers have got access to as well. You can telnet into the system, and actually this is where you can do some testing for things like the Stormworks syntax. Now, the calculation that I used is leveraging an average. And again, this is exactly the syntax that I used in my user-defined polling collector. And we've got 9 o'clock to 7 o'clock, Monday through Friday. And it's coming back with a sample as, the representation or the actual data point for that average. But you can do the same thing for things like percentile. So you can, instead of average, I can actually do a percentile calculation. And then at the end of this, and we could send the syntax out for these as a couple of examples as a follow-up as well. But I'm actually looking at 95th percentile. So I'm looking at a percentile over the course of that daily average with prime time. So show me 95th percentile only between 9 and 5, Monday through Friday. I can actually take that a step further, because one of the things that I was doing some work with is even leveraging things like standard deviation. So apply a standard deviation calculation to look at the spread of data. How far apart is the mean from the other data samples, and only focus a standard deviation, again, over that prime time calculated period. So it would be actually easy for me to take this and just change this on the fly to test other values. So say I wanted to look at prime time being only Wednesday through Friday, and I would change this to a 3. What you can see as I come back is a null sample, because it's not actually giving me any data, because today is, I'm looking at yesterday, so I'd be looking at Monday's data, and that falls outside of my prime time. So the debug, using the debug to be able to interactively test some of your calculations is very handy. It's something it's a good skill to have, and it's a good thing to test with.
Great.
That's it.
Thank you very much, Pete. Pat, do we have anything else?
No, that's it.
Okay. Right. Well, at this point, I'm going to go back here. I'm going to just step on a bit. Right. So, as I mentioned earlier, the ENA Help Center is a wonderful resource. Don't overlook it. There is a goldmine of information and all of those tutorial videos covering a lot of topics, including a lot of stuff on user-defined polling in there. It represents the product documentation. So that all of our documentation is now online and searchable rather than having large, unwieldy PDF files, which is the old way of working. And lots of additional facilities and resources available through there. Don't forget, all of the Tech Talks, the archive of previous Tech Talks, are available from the video section in the Help Center. Good way of getting at it. So, if you've got any further questions about today's content, be sure to contact your Intuity system engineer. We're always willing to help with this type of request. So we're here to help you get more out of ENA. And lastly, should you have any suggestions for a future Tech Talk topic, please let us know. Send your ideas to tech.talks@intuity.com. We really would like to know what you would like covered. So, with that said, thanks for attending today's Intuity Tech Talk, and have a great rest of the week.